For pretty much all of human history, our thoughts, our memories, our dreams, they've been the most private places in the entire universe. But what if they weren't? What if we could actually plug into the brain and see what it's seeing? Well, today we are diving deep into the incredible, mind-bending science of decoding the mind.
No, really. Just stop and think about that for a second. Imagine playing back a dream from last night like it was a movie, or seeing a memory you cherish with perfect crystal clarity. This isn't science fiction anymore, folks. This is the absolute frontier of neurotechnology. So the question is, where do you even begin to tackle a challenge that big?
You start right here by understanding the sheer scale of the problem. Every single second, your brain is processing about 11 million bits of sensory information. That's everything: the light hitting your eyes, the sounds in the room, everything. Now, what's wild is that our conscious mind, we only handle about 50 of those bits. The rest is this huge, hidden ocean of neural processing. The goal is to tap into that fire hose of data and make sense of it.
So, how do you actually build a blueprint for reading a mind? Well, it's this amazing process that combines some incredibly precise hardware with some seriously brilliant software. Let's walk through it, from the first spark of a neuron to a finished picture.
Okay, step one is all about location, location, location. You can't just listen to the brain from anywhere. You've got to go right to the source. So scientists place these tiny, ultra-sensitive electrode arrays in very specific spots. If you want to see what a person is seeing, you go to the visual cortex. For sound, the auditory cortex. And it gets even cooler. By targeting the hippocampus, we can start to access memories. And by listening to the prefrontal cortex, the system gets what is basically a built-in reality checker. So once those electrodes are in place, the data flows through this pipeline. First, you acquire the raw signals. Think of this as the brain's electrical chatter. Second, you gotta clean that data up. The body is electrically noisy, so you need filters to get rid of all the interference from muscles and stuff. Third, and this is where the magic happens, an AI model decodes those clean signals. And finally, you visualize the output, turning those signals back into images and sounds we can understand.
That magic decoding step, it's powered by a specific kind of AI called a convolutional neural network, or a CNN. And the way you teach it the brain's language is amazing. Researchers show a person thousands and thousands of different images while recording their brain activity. The CNN looks at the image, then looks at the brain signal it created. It does this over and over until it learns the pattern. Eventually, it gets so good it can work in reverse. It can look at just the brain signal and reconstruct the image from scratch.
Okay, so the system can see what you're seeing. That's incredible, but here is the billion-dollar question. Your brain activity looks pretty similar, whether you're actually seeing a cat, just remembering a cat, or dreaming about a cat. So how on earth does the system tell the difference? How does it do a reality check? This right here is the fundamental question the whole technology has to be able to answer. I mean, to be useful, it can't just spit out images. It has to know their source. Is this something happening in the real world, or is this an internally generated thought? Well, the answer is hidden in these key neural signatures. See, when you're genuinely looking at something, the signal in your early visual cortex is super strong, it's detailed, the data flows feed forward, from your eyes inward. But when you're just imagining something, that signal is weaker, it's coarser, and the data actually flows feedback from the higher parts of your brain outward to create that mental picture. It's a totally different direction of flow. And one of the most important players in all of this is the prefrontal cortex. You can think of it as the brain's referee. It's constantly doing a reality check. And its activity level is a massive clue for the system to figure out whether what it's decoding is real or just imagined. Now, when it comes to detecting something like a hallucination, the system gets even more sophisticated. It's not just one check, it's a whole series of them. It looks for a sensory mismatch, like, is the visual cortex going nuts, but the system's external camera sees a blank wall? It checks that reality network we just talked about. It can even analyze for contextual plausibility, like, hey, is that a flying pink elephant? And it looks for weird, unnatural patterns over time. So what about dreams? Well, for dreams, the system identifies the unique biological state where they happen, REM sleep. By monitoring your brain waves, your eye movements, and your muscle tone, it knows exactly when you've entered that stage. Your brain activity is super high, almost like you're awake, but your muscles are basically paralyzed. So any visual or auditory stuff decoded during that specific window gets a tag. This is a dream. Simple as that. This technology is, and I don't think this is an exaggeration, world-changing. But with that kind of power comes a profound responsibility.
We can't just build it and see what happens. We have to think really deeply about the human element and about the rules we need for this completely new frontier. And we have to be brutally honest about the potential for misuse, because it is serious. Without the right safeguards, this could be used for coercive interrogation, for employers to spy on their workers' thoughts, or even for someone to hack a neural interface to steal information or, worse, inject false data. These aren't small risks. They get to the very core of who we are.
And that is exactly why the safeguards have to be built in from day one, non-negotiable. We're talking unbreakable, military-grade encryption for all neural data. Absolute user control, meaning you and only you get to decide who sees your data or if it gets deleted. Explicit, informed consent for everything. And we need to develop new legal frameworks, what some people are calling neurorights, to legally protect our right to mental privacy.
This isn't just another new gadget, right? As this quote puts it so perfectly, we're interfacing with the very essence of who we are. The level of care and respect and wisdom that's required to develop this stuff responsibly, it just can't be overstated. So, as we stand here, right on the edge of this incredible new world, it leaves us with one final massive question. We've always taken for granted that our minds are our own private space. As that barrier starts to become permeable, the challenge for all of us is to figure out, together, how we are going to protect this last private frontier.